Hello everybody. So today we're going to be talking about what a tree is in competitive programming. So you've heard about what graphs are, which are basically structures with nodes and edges. Like a graph might look like this. I don't know, it could look like this or like this. So a tree is a type of graph, but it's a special type of graph. And by definition, it's a graph that has n nodes and n-1 edges. So that means that there is always one unique path between any nodes in a tree. So let's see what this might look like. So it can look like a literal tree like this. So hold on. Yeah, this is like the stereotypical what a tree looks like. So in this particular tree is called a rooted tree. So in a rooted tree, one of the nodes is called the root of the tree, which is this node, and all the other nodes are under this root. So we can check the n-1 edges and n nodes. So in here we have 5 nodes and 4 edges. So that by definition is a tree. And we can see that there is one unique path between any 2 nodes. For example, from this node to this node, there is only this path right here. There is no other path. And from this node to this node, there is only one path too. You literally can't find any other paths. And that is a tree by definition. Here. And yeah, so we talked about rooted, the idea of a rooted tree. And let's talk about some terminology, I guess. So the leaves of a tree are the nodes with only one neighbor. So for example, like nodes with, if you look at it as a graph, then it won't have any other neighbors other than the one. And essentially a node with degree 1, if you remember the graph terminology we talked about. So yeah. So for example, this node is a leaf because it has only one neighbor, and this node is not a leaf because it has 3 neighbors. So yeah. And then in a rooted tree, the parent of a node is basically the node directly above it. So the parent of this node is this node. And inversely or conversely, you can say that the children of this node are these 2 nodes. So yeah, it's nice to think that we have these terminology. And so in a rooted tree, the structure of a rooted tree is kind of recursive in a way. So if we draw like a huge tree, like maybe not a huge one, but if we just draw a large tree, then you'll see what I'm talking about in a sec. So yeah, this is like a tree, and you can see that each tree is consisting of like subtrees. So for example, you can say that this is a subtree and this is a subtree, and these will both be valid trees. And trees don't have to look like don't have to look this obvious. It doesn't have to have a root. So you can see, for example, here. So we can draw this, and then let's say a node here, and then 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 maybe even a node here. So yeah, this does not look like a tree at all, but it is still by definition a tree because it has 1, 2, 3, 4, 5, 6, 7. It has 8 nodes and 1, 2, 3, 4, 5, 6, 7 edges. And there's still only one path between any 2 nodes. So yeah, this is basically what a tree is, basically like a special graph. And there are tree traversal algorithms that go through trees. And there are also binary trees, which I'll talk about later. So yeah, goodbye.